Good morning, students. So today we are going to deal our second chapter, that is matter around us pure. This matter around us is pure. Okay, and one question mark is also there. That means we have to decide whether the material which is present, that is matter present in our surrounding, is it pure or not. Okay, so before that, we should know the objectives of this lesson. What we have to going to learn in this chapter. Okay, so these are the objectives. The first. So in the first chapter we already know that what is matter, which are the different types of matter, and which are the states of different matters: solid, liquid, gases. These are the different states of matter. Okay. So in this chapter we should know what is mixture. What is mixture? What is different types of mixture, that is types of mixture. We have to learn about the types of mixture. Okay, and after that the properties of solution, and the fourth one is that how to separate different components of a given mixture. So these are some important points that we have to deal in this chapter. Okay, we have to collect the knowledge about this topic. Okay. First of all, we will collect a list of material which is present in our surrounding. For example, we are having the water, we are having air, we are having suppose glass items. Okay. Again, so air, this water, it is in liquid state, air is in gaseous state, glass items they are in solid state. So this is about the solid. But suppose I have a sample of muddy water, the water which is not clean, okay. Then I have, suppose we can say a mixture of sugar plus sand. Okay. Then again, suppose I have prepared a mixture of salt in water. Generally, if a small child or anybody is having the problem of loose motion or dysentery, we are taking some water in a glass, we are putting some pinch of salt and some sugar and mix it completely. Then that material we are giving that person to get a relief, because that is an energetic drink, we can say. Then again we are also preparing the nimbu pani. It is called as lemonade or lemon sharbat. Okay, so these are the different types of material, we can say. And if we observe these examples, okay, this muddy water not contain only water, it contains some soil particle also. It may contain some germs also. So sugar and sand, this mixture contain the sugar particles and sand particles. This material contains the presence of salt and water, but actually here the salt particle we cannot see when they completely mix together. Then in nimbu pani or in lemonade, we are adding the salt and sugar, water, etc. Lemon juice. Okay, so that means here these materials are formed or get prepared by the mixing of different materials. and that is nothing but the concept of mixture. So mixture. So mixture is made by combination of two or more than two pure substances. For example, here the sugar plus sand. Sand itself is one pure substance. Sugar itself only a pure substance. For example, in a beaker, I have a sugar particles. I have taken the sugar. In another beaker, I have taken the sand particles. So these are the sand particles. Okay. If I pour the sugar in this beaker that contains sand, then what happens? So the sugar will take the place where it gets some gas. Okay. So here now it contains the mixture of sugar plus sand. Sugar plus sand. Okay. Sugar itself, it's a one pure substance. Sand itself one pure substance. Again, this is one example. Second example here I want to give that a mixture of salt in water. I have taken a beaker. In that beaker I have taken water. Okay, what I have added here, that is water, and one spoon of salt, that is common salt, our table salt, that is sodium chloride. It's a white color material we are using in cooking. Okay, this salt, or it will mix together and we get a clear solution here. So that means the salt and water, they are already a pure substances and we are mixing together. Okay, so the mixture is a combination of two or more than two pure substances. Mixture is a combination of two or more than two substances. Okay, so that is the definition for mixture. Okay, so then here the types of mixture. Actually, I want to first of all, before going to the type of mixture, we will start from the matter. Actually, matter. Okay, so matter in the surrounding, that may be solid, that may be liquid, that may be gaseous one. Okay, found in our surrounding, that matter made by the pure substances. Okay, or that matter may be of different mixtures. So this is the classification of matter. Okay, then here the mixtures. We know that mixtures, these are the when the two or more than two pure substances get mixed together, then we get a mixture. Again, the mixtures are of two types, that is homogeneous and heterogeneous. Okay. So here again, pure substances are of two types. That one is element and another is compound. Okay. Briefly, I will explain here. Then later on, we will take it in detail. So element. Suppose I have a piece of copper wire. Suppose this is a copper wire, or this is one iron nail. This is iron nail, or this is a copper wire. So copper wire itself, it contains only the atoms of copper. This is iron nail, contain only the atoms of iron. Our gold ornaments, they contain only gold atoms. So these are the element. Okay, a pure substance. That means it contains only iron and iron. This wire contains only copper and only copper. Okay, this is about the element. Then compound. Compounds are, these are the materials which are formed by the combination of two or more than two atoms of different elements. For example, this H2O, that is water, is a compound. It's a chemical compound. How it is formed? It formed by the two atoms of hydrogen and one atom of oxygen. Okay, so it's a compound. Then again, sodium chloride, NaCl, our common salt or table salt. How it is prepared? It is prepared by sodium atom and chlorine atom. Atom of sodium element and atom of chlorine element. Okay, so these are the formulas of chemical compound. One more chemical compound, that is copper sulfate. That is copper sulfate. Okay, copper sulfate, for example, formula is CuSO4. It is formed by combining copper atom of copper element, atom of sulfur element, and 4 atoms of oxygen element. Okay, so this compound in a fixed ratio. Here all these atoms, they join together in a fixed proportion. Okay, then and then only these compounds are formed. Okay, so simultaneously we will take the examples also. That is iron, copper. Then these are the metals. We will see the non-metal also. Then hydrogen, then chlorine, etc. Here compound, that is water, then copper sulfate. Okay. So now we will move toward the mixture. Mixture, they are formed by the combination of 2 or more than 2 types of pure substances. Okay. So here again the 2 types, homogeneous and heterogeneous. So homo means same. That means if the 2 different components, suppose the 2 components are there in a mixture, if they completely dissolve together, mix together, and we will get a complete only single phase, single state of matter, then it is called as homogeneous mixture. For example, this homogeneous mixture is called as solution. Okay, the solution may be liquid, solution may be gas, solution may be solid. For example, so one, that is air, that is a mixture of different gases, so it's one of the solution. Then that is solution of salt in water. It is a solid in water. Solid in water solution. Salt is solid and water is a liquid. So solid in water. Then third, liquid in 1 minute. Then mixture of alcohol and water. Alcohol and water both are the liquids. So this is liquid in liquid. Liquid in liquid. So in this way we can prepare the different type of solution. But the point is that these components should mix together. Okay. So again hetero. Hetero means here different. Okay. That means if we combine together the different components of a mixture, if we are not getting a single phase or single state of matter, and we can identify from our naked eyes only, so which are the components present. For example, salt in water. Suppose salt is dissolved in water, we cannot see the salt particles in water. We only get the liquid only. Okay, so we cannot guess whether salt is present in that material, in that solution, or that sugar is present or salt is present. Okay, because we are getting only liquid material, that is water. But in heterogeneous mixture, we can identify the different components by our naked eye. For example, mixture of sand and water. Mixture of sand and water. So suppose I have taken a beaker, in that water I filled, okay, and I pour some sand particles. So we can easily identify the sand particles because their size is large. Okay, we can separate which is sand and which is water in that container. Okay, so again this mixture, these heterogeneous mixture are of 2 types. Okay, called as colloids and suspension. Okay, so this mixture of sand and water is the example of suspension. This is the example of suspension. And colloids, for example, our milk contain the proteins and water. Okay, so this is the example of colloids. Then jams and jellies, these are also the example of colloidal materials. Okay, so this is about the classification of mixture actually, but I started from the matter. You have to note it in your notebook. Then focus on the main point, that is solution. Very important. What is solution? Solution is a type of homogeneous mixture. This is our first point. Okay. Solution is a type of homogeneous mixture. Then how the solution is prepared? Okay. So to prepare the solution, we need the two components. One is solute and another is solvent. Then when these two mix together, okay, we get solution. Okay. So solute. So what do you mean by solute? The component or the part of a solution which is present in less amount, that is called as solute. And the solvent means the component or the part of a solution which is present in large quantity or large amount, that is called as solvent. Okay, I will give you one example. That is solution of sugar in water. Sugar in water. Suppose I have taken in a beaker 100 ml. This is 100 ml water. Then I pour 1 gram of sugar. Okay, then I will completely mix it. Then after some time I will not see the sugar particles because they mix together with water. They mix in water. They dissolve in water. Okay, and after that you will get a clear only one phase. See, the sugar is in solid state or solid phase. Water is in liquid state or liquid phase. But after mixing the sugar, we are getting only liquid state of matter. Okay, so this is the example of homogeneous mixture. This is the example of solution. Okay, so then what is the properties of the solution? In solution, the solute and solvent particles or molecules or materials, they mix together. Okay, we can't see by our naked eyes the solute particle in solvent because they completely mix together. Okay, and we get a complete clear solution, that is called as true solution here. The solution is also called as true solution because the solute particle size is very small. Then the next point, that is concentration. Concentration of a solution. So what do you mean by concentration of a solution? Concentration of solution is related to how much amount of solute present in your solvent. Okay, what is the quantity of the solute present in a solution? That is called as concentration. Okay, and this concentration of a solution we can find out by the different parameters or by different way. But in our book only 3 ways given, that is by mass by mass percentage, by mass by volume percentage, then third by volume percentage. Okay. So what is this mass by mass percentage, mass by volume percentage, volume by volume percentage? Okay. Okay. So we are taking the solute, which is a solid one. We are taking the weight, that is mass of that solid. Okay, and we are taking the mostly the solvent in liquid form. So volume is related to liquid material. Okay, so we will see the first mass by mass percentage. Okay, so concentration of a solution by mass percentage. So mass by mass percentage is equal to, that is mass of solute divided by mass of complete solution multiplied by 100. So here the mass of solution, how we calculate it? By adding the mass of solute plus mass of solvent, because solution is a mixture of solute and solvent. So if you combine the mass of solute, that is weight of solute, and the mass of solvent, we will get a complete mass of solution. Okay, so this is the formula. Then if you are taking mass by volume, then we are taking the mass of solute divided by volume of solution by multiplied by 100. If you are taking third, that is volume by volume, then we are taking the volume of solute and volume of solution in numerator and denominator respectively multiplied by 100. Okay, so we will take one example. Okay, if a solution contains 40 gram of solute and 360 gram of solvent, then find out the concentration of given solution in mass by mass percent. Okay, so our formula, mass by mass percent is equal to, you have to write the formula first, then